Hi, welcome to this Esko Software Solution Demonstration series. My name is Bart Meersschaert, and in today's demonstration, we will be covering ArtiosCAD Enterprise and how it can help you to very quickly build a point of purchase display, as you can see here on the screen. Stick around until the end because as a bonus, we'll show you how you can easily change the dimensions of this point of purchase display and repurpose it for another use. All participants have been muted, and at the end of this demonstration, we will unmute for Q&A. Stay tuned for additional sessions. An event calendar is hosted on esco.com/brand solutions. So for today's demonstration, we will switch over to my Windows computer, and we will show you here in ArtiosCAD how you can easily create a point of purchase display. As we show you this, we'll also show you some 3D tools and how Studio can help provide graphics for these displays. And then at the end, as promised, I'll show you how you can easily change those. Now, looking at the screen here in ArtiosCAD, you can see that point of purchase displays are typically multi-component displays. And with that, we have added complexity. Complexity from a construction standpoint, complexity from a standpoint of how all these different components come together in the final POP display, and complexity in a sense that each of these different parts can be built from different materials. And then finally, we want to make sure that we can create a POP display that will be functioning in the store. My starting point is going to be the display store that you can see right here. Now you're probably asking, what is the display store? Well, right here in ArtiosCAD in the File menu, I can click on Download from the Display Store, which will automatically open up a browser. In this browser, in my case Chrome, I can see that I have been brought to this esco.com ArtiosCAD Display Store. I can visit the store by clicking on this button right here, which will show me a list of lots and lots of different folding cartons, displays, any type of display that you could possibly think of. Now you can see here that I have filtered this store to only show me free displays. Let's go ahead and get rid of that search criteria. And with that, you can see now that this store contains a lot of different types of displays. So this is a great starting point if you, as a structural designer, or even as a graphic designer, if you don't have a lot of knowledge on how to build these, this is a great starting point to simply select the display that you are looking for, download it, and start working from this. You can see here that these displays are also categorized. So if you're looking for a specific type of display, like a counter display or a corrugated box or a freestanding display right here, you can do that. And you can also filter here in thickness, in this case millimeters, but you could change that to inches as well. So for my proof of concept, I am looking for free ones, right? The price is right. Free is always good. So we are looking in the store and we found this beautiful display right here, which is about 1.7 meters, so 1720 millimeters. It's about 610 wide, 290 deep, and the material thickness right here. It's accompanied by a little video that gives you a good idea of how this display folds up. So here we can see one of the trays that is folding up. It's rotating here. And then, you can see here also a little movie animation of how the actual base is folded up. And then the trays are matched inside right here, the POP display. It also comes with a little 3D PDF right here. So what we're going to do for today's proof of concept is simply click on the download button here. Let's try that again. So click on download and provide my user credentials. You can create a username and a password, and the instructions are listed for you. So again, let's go ahead and search for that free one. Select that right here and click on this download link right here. So let's wait for a second. There you go. And the download started and the download is finished. So let's go to my download folder, and indeed we can see right here the 20520.zip file. So let's go ahead and extract this right here. So we'll extract this to a folder with that same name. Why not? And as I open up this folder, I can see that there are quite a number of files in there. So let's have a quick look before we open this in ArtiosCAD. So we have a nice JPEG showing me what the final product will look like. We have a preview with variables, really interesting. Let's double click on that and show that a little more close up. As you can see, we can switch here between millimeters and inches. So this will work regardless where you are based. And then we can see the parametric aspect of this POP display. So all these variables I will be able to change. So initially, I am just going to keep the initial values that are listed, which right here is 610 by 290 by 1720. You can see each of the parameters represented here in the drawing. And at the end of this demonstration, we will make a change by increasing the width, for example, of these trays so we can store more products in there. We also have some production remarks right here. So again, these are real life POP displays. So they have been tested, and you know that if you start from them, they will work properly. We have some images right here showing you what the final product looks like in the real world. And then right here, you can see the end product with some additional products in there. So a great little set of documents right here. The file we are going to start with is obviously this one right here, which is the ARD file, the ArtiosCAD design. And then you can see that the repository also has an ArtiosCAD 3D document in there. The extension for that file is A3D. So again, ARD for Artios and A3D for the 3D. So let's go ahead and open that up. So with File, I'm going to say Open. We are going to dive right into my downloads. And in that downloads, we'll look at that folder I just unzipped. And we select the ARD file and we double click to open it. Here we are. First thing I see is Artios hinting me to the fact that some of these designs are not in my ArtiosCAD database. And that's fine. I'm not going to worry about that, so I'm just going to accept that message. Now, the first thing I see is obviously this is a multi-component design, right? This part of the POP display is the main part, the base, if you will. Here we have the part that's going to angle on this. Here we have the sights, and then we have 4 individual trays right here on this side. So working with these files in Artios, I can do by simply using all my tools I have at my disposal right here. If I would just say, okay, I'm going to accept this the way that is. So let's go ahead and add my initials in front of it, or just add Bart in front of it and save it in that folder. I can do so. If I would switch over to Adobe Illustrator and place that ARD file, I'm curious to see what we are going to get. So let me start with a new document, an 8.511, and place that structural file in there. So I'm going to have to hike on over to my Windows machine. So let's go to the let's go to the network. So this is always a little tricky because I'm actually working on a Mac, and my ArtiosCAD is located on my Windows VM part, right? So let's go ahead and connect. And if not, we can always manually copy these files over from Windows to my Mac. So can't mount for a specific reason. Let's see what we get here. If I go through here. Okay, let's not waste our time with that. So what I'll do here is I'll go back to my Finder, and let's see, bring that to the front. And what I can do is I can mount my C drive, my Windows C drive on my Mac, and I'm going to log in as the default Esko user, which is known as BG System. You can also mount with any other credentials that are known both to Mac and Windows. So here in my download folder, we created this one. Remember, we unzipped this, and here is my actual file. So I have access to this right now. So let's head on over back to Illustrator and try that one more time. So we should find the mounted volume now on my desktop. So let's go back to here. There it is. Let's go to Users, to BME, to Downloads, and to that folder. And there's the ARD file that we just saw right there, the Bart one, right? And we just open that. Really curious to see what I get. Wow, that's a pleasant surprise. So if we go to our free Trimbox and MediaBox plugin, that one you can download from our website, and then in Illustrator you will find this here in the Esko section right there, Trim and MediaBox. I've already docked that right here on the right hand side. With that, I can ask Illustrator to fit my Trim and MediaBox to that ArtiosCAD file, so I don't have to worry about anything, and then fit my Illustrator artboard to that CAD file. And then if we zoom out a little bit and we go into a contour mode in Illustrator, I can see that this is very nice. This is exactly what we were looking at in ArtiosCAD. So if I also would purchase the Esko Studio plugin, that was the one you saw initially when I opened this. And again, that is unfortunately not free, but again, you can download this from our website and give it a 30-day free trial. You'll have access to this Studio Designer window. Again, I docked that in my favorites right here. And if you click on that, this is a designer window. This will give you access to that 3D view. So now I can start applying graphics here in Adobe Illustrator, and I've already done that for you in preparation for this demonstration. You can see then that when you, right here, when all these different parts come together, you can see here my display, my first component. Right here, I created the graphics for the bottom. Then I have the tray. Let's go back to the base. I'd like to see that base. Okay, so that's the base. That's the bottom. And then we have trays for each of these different flavors. Okay, and here, yeah, that's the base right there. So I can see all these different ARD files. And once I combine those in one view, I can then see what that final result looks like. Now we're getting ahead of ourselves a little bit too much. Let's go back to ArtiosCAD and show you a little bit of the intricacies of how we can optimize this and how we can make changes. So inside ArtiosCAD, we have a concept right here that is called canvas. Now, if you're a graphic designer, you are probably familiar with that concept of a canvas from Adobe Illustrator, where you can create different canvases, and each of these canvases can represent a different part of your display. So if I select this convert to canvas, by the way, the extension for the canvas is ACD. Anybody who grew up or was a teenager back in the 70s or 80s always reminds me of the rock band AC/DC. Yeah. So this ACD file has, as you can see here, will now take that ARD file that I downloaded, and it will create what we call different parts and different canvases. Notice that for each of these parts, we have also a multiplier right there. So you can see this part, for example, is used 8 times. This part 5 right here is used 4 times. Those were the trays. Then we have our base, our sides, and right here, the angular part. On the right-hand side, we get a bill of materials, if you will. And each of these parts right here is listed. I can select these, and you can see here, for example, the tray, part 5, has a multiplier of 4. So those are the number of copies right here. And in my case, the number of copies is determined by one of those parameters. Remember when we downloaded the POP display and we looked at all the parameters, one of the parameters, an S, represents the quantity. We also have the board code and the board description. We can always click on the database information, and we can add any kind of description, author, or any type of additional information to identify that specific part. So we can see we're using an EB flute right there, and that was part of that bill of materials. So we can save that as a bill of materials right here. We can output that. We can save this right here. And yeah, so with that, let's look at how we can combine all these parts in a nice 3D. Well, as you are probably aware of, ArtiosCAD not only allows you to design in 2D, but the real power comes in 3D. This is an additional option that you can purchase, and if you simply click on the Convert to 3D, the system will take the ACD file, so all the parts, and it will show me what it's going to indicate as base face for each of these parts. I can see there is a little warning that the canvas part count does not match the saved 3D information count. So I can say, use the 3D information count, look again at the different part counts, or use the initial part count. So I'm just going to leave that for what it is. And you can see that the system did a pretty darn good job in combining that 3D into a nice 3D view. Now, there are a couple of elements right here, which are these little T-junctions, which are probably used to reinforce the trays snapping into that base panel right here. So let's deconstruct for a second and see and give you some ideas on how you can combine these parts in a 3D environment. So how to maneuver around in this 3D space? You do that using the little camera icon. So you can do that right here. Again, use your magnifier to simply zoom in by using the magnifier zoom in. We can use this one and then click and drag the mouse like so, and use the little hand to pan up and down on the POP display. Selecting individual components, you could do with the select 3D design part. So I can select this tray, for example. And then using these icons right here, we can move these individual parts in a three-dimensional space. So I am just going to move that part, and you can see when you select that part, it highlights some of the axes. So I'm going to select this axis. Once I do that, the software now visualizes, as you can see down here, my X, Y, and Z axis. So in my case, I'm going to slide that tray on the Z axis, which is this axis right here. So I can select that axis and I can move that tray any way I want in that 3D space. I'm doing that to deconstruct and show you that, we could now use that little T-junction and move that T-junction in there and then use that as like a little latch to reinforce when this part meets that part. What I also would like to show you is that if you make changes, which I'll show you in a minute, to this display, how can you easily snap these parts together? Well, for that, we embedded a really powerful tool in here that's called Snap Tap into Slot. Let me show you how that works. If I select this, I can see here that in the bottom of the screen, I will also create a mate area. And when I hover over this area, I hope you can see that in the team meeting here. The ArtiosCAD software displays a three-dimensional arrow pointing forward. So one click to indicate that this is my arrow that I want to use as half of the mate. Now we have a cursor that shows me number 2. So with that, I can now go here and I can already see a ghost image of Artios snapping that into that location that I clicked on. This little next shows me all the possible combinations of mating. So I can mate with the left tap or the right tap. I can mate that, with a reverse view like that. So I can cycle by simply clicking on the next button. I can cycle through those different options until I find exactly what I need, and then I can close that feature. So a very powerful feature indeed that allows me to quickly create the proper 3D image. Once I am done combining all these elements, I will create what we call a collada file. Now, a collada file is an industry standard file format that will save this in a three-dimensional fashion. Collada stands for Collaborative Design Agency, and it's a standard that was developed in the 90s by Sony, and that eventually the company Sony, and that eventually became an industry open source file format to exchange 3D. So selecting this, I can create Bart 3D. I can create that collada and save it. And the reason why I'm showing you this is because inside Adobe Illustrator, I can use that collada file to show me the proper 3D right here in my designer window. I have already prepared a collada file ahead of time, which I load it right here by clicking on it. But you can see that by cycling through this, you can either pick your standard ARD, which is going to show you the three-dimensional vision view of each of these, but the combined view you can show by loading those collada files right here in that scene. So from here, you can export high-resolution images, such as JPEGs, PNGs, or TIFF files, with or without background. You can see here my background is picked as a gray. Before we do that, you can also see that you can change the scene, so the lighting you can change here. And you can also opt to change the output to a movie sequence, which is essentially a sequence of TIFF files that you can stitch together in Photoshop. Again, high-resolution collada, or hand it off to KeyShot for additional realism. Now, I promised you as a bonus, if you stick around to the end, which we're approaching here, that I was going to show you how you can easily change this to a different size. So let's head on over back to ArtiosCAD, and let's say, for example, that I want to change this to a different size. So I want to increase the width of that tray. How would I be able to do that? Well, if we go back to our 2D, remember, if we go back step by step, we have our ACD file, and then we have our ARD file. We can go back into the design window right here, and we can use the rebuild design to change the dimensions of this POP display. So before we do that, let's cancel here for a second. Cancel rebuild, yes. You can also use the distance tool to kind of analyze. If you don't have the variable tool, you can quickly put some dimensions up here in that design. So I can see that the tray is 250 millimeters. The total width is 610. So let's say for this demonstration that we want to increase the width of that tray to 500 millimeters. So 610 minus 500 will give us 110, divided by 2 will be 55. So if I want to evenly space that left and right, I'm going to need 55 millimeters on each side. I hope that makes sense. So back into that rebuild design. With that information, the SL parameter, we are going to double to 500. This will stay the same. We got 80 right there. LE is the left side. We calculate it as 55. We got 500, 170, and 4. We don't need to change that. Let's go to the next screen. And then we can see here that we can indicate the height, the width, and the base. So again, for the BL parameter right there, that should be 300, 66.7, 200, 301.5. BL, let me just check before we commit to that. Let's go back to this variable right there. I want to see exactly what that BL stands for. So that is the body length right there, BL, body length. So that's a parameter I also want to change, right? So I want to make that 55 millimeters. Okay, so let's head on back. And this one also needs to be 55. So drum roll, please. Let's see what we get. And what do you know? Not only did the dimension of the POP display change, but the dimensions updated, and most importantly, the gaps right here, the mating area, in order for these trays to match the change, also automatically updated, as well as any other dependent component. That's pretty awesome. So with that, I can go back and create my canvas. I can close the previously converted one and create a new one. And then I can simply now update my 3D by clicking on Update or deciding to create a new 3D. And seconds later, we have our new width, 610. My trays are 500. And now we can go in here and we can use the tools that I explained earlier, the mating area tools, so I can do that. Some of these right here, we'll have to manually select this. This is probably not folded properly, so I can go into my folding tools and select some of these lines and start figuring out, you know, how I need to change this in order for this to be precisely the way I want it. So that's probably got to be minus 90 degrees, like so. And so as you continue folding and positioning these components properly, you save your final result, make your collada file, come back into Illustrator, and you know, reapply your artwork for the new POP display. So with that, I wanted to show you in this demonstration how ArtiosCAD can really help you starting from this display store to download the display that you need. Even if it's not exactly what you want, these displays are parametric, saving you a lot of design time and, you know, the peace of mind that you know that these displays have been tested. I showed you also that these multi-display components can come together in an ACD file, which is a canvas that allows you to assign different part number of copies for each of those and materials. And then finally, turn this into a 3D where I showed you how you can move components and how you can view this and snap components together. Last but not least, we showed you how you can then take that collada file and bring that collada file into Adobe Illustrator, where you can now start designing and add your graphics to this POP display, and then finally produce output.